You know, it's one of those things that you probably learned about in primary school, where you hear about how the doctor comes in with a little hammer and hammers below your knee and it causes your knee to jerk. The knee jerk reflex. I don't know about you, but when I went back and I tried to do it myself, it didn't quite work. Doesn't work all the time. Maybe you just need to hit the right point. So we'll come back to class and we'll try it. If you can do it by yourself, you can try it. But it is a scientifically proven and well documented reflex that happens. And in this video, we're going to take a look at how such reflexes are produced in the body, produced by the nervous system. Yeah, so what is a reflex action and what is the pathway in the nervous system that produces a reflex action, right? What we call the reflex arc. So what is a reflex action? Well, it is an immediate response to a specific stimulus that is without conscious control. So it's involuntary. For example, you are hit on the knee, specific stimulus below the knee at a particular point, and the immediate response is that your knee jerks up, and you cannot do anything to control it. It's without conscious control. Now the question is, are all involuntary actions reflexes? So for example, you might think of your heart rate increasing when you are running, or when it gets cold, your hair erector muscles contract, causing your hairs to stand. Would you consider those reflexes? Looking at the definition. Well, if you want to be very particular, these are not reflexes because they are not immediate responses and they are not responding to a specific stimulus. For example, when your heart rate increases, that's not exactly immediate, right? It happens over a period of time, and so is your hair standing when the weather around you gets cold. So reflexes need to be very immediate, right, and to something that's specific. So here are other reflexes which you might have experienced in your daily life. For example, if you wear contact lenses, or you put eye drops into your eye, what makes it so difficult? Well, it's when you try to put it in, your eye will blink, right? So there's such a thing called the blinking reflex, which kind of protects your eyes when there are unexpected stimuli coming into your eye. And then again, there's the reflex you get when you touch something hot, immediately your hand is removed. In fact, so often, it happens without conscious control, right? You touch the hot item and you remove your hand even before you realize that it was hot or that it's painful. You only feel the pain after that. So these reflexes are very important for protecting your body. Is it under conscious control? Not really. And that's why it is a reflex action. So there are two types of reflex actions: cranial reflexes and spinal reflexes, depending on whether the brain or the spinal cord is involved. So cranial reflexes are reflexes that involve or are controlled by the brain, and these reflexes usually happen in your head region. For example, when you blink, or when you look at food and then you start to salivate, have saliva, or the pupil reflex, which we'll look at in the eye chapter, where the size of your pupil changes. So cranial reflexes involve the brain, because the organs that are involved are usually in the head region, which is nearer to the brain. So for example, the eyes, when something like wind blows into your eye, that stimulus is picked up, information sent to the brain, and then the brain will send back information to the eye to cause it to blink. Spinal reflexes are controlled by the spinal cord. So they involve the spinal cord, and they usually involve the regions of your body that are below the head. Right? So the spinal cord, let's draw the spinal cord. And then let's say, for example, your knee jerk, right? So information sent from your knee to the spinal cord, and then from the spinal cord back to your knee or your leg to cause it to jerk. Right? So that just involves the spinal cord, and that's why it's a spinal reflex, right? It doesn't involve the brain at all. So how are reflex actions produced? Well, to explore that question, we're going to take a closer look at one example of a reflex action. And the example we're going to use is the withdrawal of your hand from a hot object, like a hot plate, or a hot bowl, or hot pot. Right? And how is that reflex action produced? Well, it begins with the stimulus. The stimulus is the heat from the hot object, which stimulates the receptor. Right, so a receptor in your skin is stimulated by the heat, nerve impulses are produced. And then the sensory neuron, over here, sensory neuron, follow it. This sensory neuron transmits the nerve impulses from the receptor to the spinal cord, right, to the gray matter of the spinal cord. So this diagram should look familiar to you. Now in your central nervous system, in the spinal cord, nerve impulses are transmitted across a synapse. Here's the first synapse, from the sensory neuron to the relay neuron, and then from the relay neuron to the motor neuron. Right, and next, your motor neuron transmits the nerve impulses from the spinal cord to the effector, right, which is the muscle in this case. And the effector, which is your biceps muscles, will contract to withdraw your arm very quickly from the hot object. So you might have noticed that there's another relay neuron here, which carries information from the spinal cord up to the brain. So what does that do? Well, to understand that, let's go back to our sensory neuron. So the sensory neuron was transmitting nerve impulses from the receptor to the spinal cord. Now remember, it passes on the information to this relay neuron here. So there's one synapse. Now, however, the sensory neuron also, right, forms another synapse with another relay neuron, but that relay neuron brings information up to the brain. Okay, so it's a different relay neuron that brings information up to the brain. And this relay neuron that carries impulses from the spinal cord to the brain is what allows your brain to interpret the impulses and to produce the sensation of pain, ouch. So it's only at that point that you feel pain. Now, an interesting question to consider is, do we experience the pain first or withdraw our arm first? Think about the length of the pathways. You should realize that the reflex pathway is shorter, right? So from the receptor to this relay neuron that's very short, the motor neuron and back, that's a very fast pathway. So you actually withdraw your hand first, and then slowly then you sense that sense of pain, because there's more time needed for this relay neuron to carry nerve impulses up to your brain, and more time needed for you to actually interpret those signals as pain. So your body protects you first before it makes you feel the agony of the pain. So what we've just looked at is a reflex arc, alright? So the reflex arc is the pathway that produces the reflex action. Okay, so from the receptor to the sensory neuron, to the relay neuron, to the motor neuron, to the effector. That's a reflex arc. Right? So from the receptor, what's a reflex arc? From the receptor to the sensory neuron, to the spinal cord or brain. Okay, in the case of a cranial reflex, it will be to the brain. And then to the motor neuron, and then to the effector. And that produces the reflex action. So the reflex arc is the shortest pathway by which nerve impulses travel from the receptor to the effector in the reflex action. So it's a very short pathway so that it will happen quickly. Now, question. What do you think is the fewest or the least number of neurons that you need to get from a receptor to the effector, right, in a reflex arc? You might think 3, right? Because so far we've seen examples 3. Sensory neuron, and then relay neuron, and then the motor neuron, right? And then you get to the effector. However, there are reflex arcs which are even shorter, which actually only require 2 neurons. So there are some reflex arcs where from the receptor, right, information is carried by a sensory neuron into the central nervous system, and we don't need a relay neuron. The sensory neuron immediately synapses with a motor neuron, which carries information to the effector. So really the least number of neurons you need in the reflex arc is 2. And in that sort of reflex arc, there's only one synapse between the sensory neuron and the motor neuron. So here's a slight extension, right, of that point. So for example, you can see here on this side, this is called a mono, meaning one, synaptic reflex arc, monosynaptic, where from the receptor, the sensory neuron transmits nerve impulses into the spinal cord, and the sensory neuron directly communicates or synapses with the motor neuron, which carries the information to the effector organ. Now an example of a monosynaptic reflex is actually the Kneejerk reflex. It only has one synapse, where from the sensory neuron information immediately nerve impulses are passed on to the motor neuron. Now, most other reflexes, like the withdrawal of your hand from a hot object, is a polysynaptic reflex. It means there's more than one synapse. In this case, right, from the sensory neuron will first transmit nerve impulses to the relay neuron, and then from the relay neuron will transmit impulses to the motor neuron. So it's slightly longer. So in both cases, the reflex arc will definitely pass through either the spinal cord or the brain. But inside the spinal cord or the brain, there may or may not be relay neurons. So in the case of the monosynaptic reflex arc, there are no relay neurons. Right, before ending off, we're just going to look at a few more reflexes. So firstly, there's the pupil reflex. I mentioned that. It's a cranial reflex. So for example, in bright light, right, we know that the pupil, that hole in your eye that allows light into your eye, the pupils will constrict so that less light enters. And in dim light, your pupils will dilate and become bigger. This is an example of a pupil reflex. It is controlled by the brain. And we'll see more of it in lessons on the eye. And just a bit more information on the Kneejerk reflex and how it's supposedly supposed to work. So here is the point where they hit your knee, right? There's actually some stretch receptors. When I hit your knee here, there's some receptors inside your quad muscles, your thigh muscles, which are stretched, and so they will produce impulses, right? The sensory neurons will transmit the impulses to your spinal cord, and like I said, there's only one synapse, right? Sensory neuron will directly pass on the information to your motor neuron, right? So the nerve impulses will transmit across the synapse to your motor neuron. From your motor neuron will transmit the impulses to your effector, and causing your quad muscles to contract, causing your leg to swing upwards in a jerk. Now, before we end, I would like you to think of one question, and that is, what are the similarities and differences between a reflex action and a voluntary action? Alright, what are the similarities and differences? It's a question that's often asked in the exams, so I want you to brainstorm a bit, think about what we've learned about reflexes, what we've learned about voluntary actions. Think about, for example, where does the pathway start, right? Where does the pathway end? What does the pathway involve? Is it conscious or unconscious? Right, so come back to class, we'll discuss this after the holidays. And till then, enjoy yourself and have a good break.